This is the two-way frequency table notes for page 36 through 39 in your journals. Two-way frequency tables are where some data sets include categorical data and consist of category labels rather than numbers. A two-way table displays two variable data by organizing it into rows and columns. So how do we construct these tables? Maria took a survey of pet owners to find out whether cats and dogs prefer being inside or outside during the day. Construct a two-way table for the results. 35 out of 50 cats prefer being inside, and 20 out of 50 dogs prefer being inside. Identify the two variables and create the rows or columns for them. Then use the information given to complete the table. So we're talking about cats and dogs and whether they prefer being inside or outside. "35 out of 50 cats prefer being inside," so 35 are inside out of the total of 50. 20 out of 50 dogs prefer being inside, so 20 are inside out of the total 50. And now we fill in what's left. If my total is 50 and 35 of those 50 prefer being inside, then 15 prefer being outside. If 20 out of 50 dogs prefer being inside, then 30 out of 50 dogs prefer being outside. There's a total of 55 pets, 35 plus 20, 55 pets prefer being inside. 15 plus 30 is 45, prefer being outside. And there's a total of 100 pets. 50 plus 50 is 100, 55 plus 55 is 100. What do the totals or cumulative frequencies allow you to see? It allows you to see how many pets like being outside. To see the total. Finally, include the relative frequencies with each of the results in a two-way table. So again, we have cats and dogs. Inside or outside. There's the 35 out of 55 total that like being inside that are cats. There are 20 out of 55 total that like being inside that are dogs. So the relative frequencies is how many cats is it compared to everyone likes being inside? How many dogs is it compared to everyone likes being inside? So you're making ratios. There's 15 cats that like being outside out of 45 total animals that like being outside. 30 of the 45 are dogs. Alright, let's look at it. Interpreting a two-way table. The two-way table shows the results from a survey of dog and cat owners about whether their pets prefer dry food or wet food. Complete the table by finding the cumulative frequencies. Cumulative is your overall, adding them all together, and the percentages. Does the two-way table show any differences or in preferences between dogs and cats? Explain. So, I have 10 cats that like dry, 30 cats that like wet food. That's a total of 40 cats altogether. 20 dogs like dry food, 20 like wet dog food. That's 40 altogether. So 40 plus 40 is 80 total pets. 10 cats out of 40 cats prefer dry food. So 10 out of 40 is going to give us 25%. That means the 30 out of 40 will give us 75%. Same thing with the dogs. 20 out of 40 dogs like dry food. 20 out of 40 gives you 50%. Which leaves 50% for the wet dog food. And how many total animals prefer dry food? 10 plus 20 is 30. So the 10 out of 30 for the 10 cats that prefer dry food out of 30 total animals that like dry food, that is 33%. That's 1/3. Which leaves 67% for the dogs. And 30 plus 20 is 50 total that prefer wet food. 30 out of 50 is 60%. You just divide those numbers, which leaves 20 out of 50 is 40%. And so what does this tell us? This tells us that more cats, there's 60% that prefer wet and only 40 of dogs that prefer wet. So more cats prefer wet food than dogs. And 67% of dogs prefer dry food and only 33% of cats. So more dogs prefer dry food than cats. So this is just like when we had to interpret what was going on with the qualitative crafts. You are figuring out, you are interpreting this using your own words. It does not have to be verbatim what I say. Alright, example 2. The data from a survey of 7th and 8th graders about their sports preference is shown. Complete the two-way table with cumulative frequencies and percentages, then describe any relationship you see in the data. So out of 7th grade, there's a total of 15 plus 15 is 30. And for 8th grade, 45 plus 45 is 90. 15 out of 30 7th graders prefer soccer. That is half. 15 out of 15 7th graders prefer basketball, which is also half. 45 out of 45 8th graders prefer soccer. That is half, which leaves us with half for our basketball. 15 plus 45 is 60. So there are 15 7th graders that prefer soccer out of 60. 15 divided by 60 gives you 25%, which means that 75% of students who like soccer are 8th graders. 15 plus 45 is again 60, and these numbers are the same, so 25% are 7th graders, 75% are basketball players, and there's a total of 120 students. Describing the relationship you see. Well, you see that the survey was only given to 30 7th graders, so it makes sense that these numbers are so much lower. It doesn't necessarily mean that the 8th graders like the sports better, it just means that 8th graders were surveyed more than 7th graders. So the survey was given to 3 times as many. Three times as many 8th graders as than 7th graders. So the percentages show that 8th graders like sports more. However, that is not accurate. In order for you to have an accurate survey, you have to survey the same amount of 7th graders as 8th graders, so this survey is not accurate. Alright, page 38. Two-way frequency tables. Information is arranged in rows and columns to display bivariate data, because we have 2 sets of data, so like what we just looked at, cats and dogs versus inside-outside, that's bivariate data. The end goal is to compute relative frequency, how often will that event occur. Alright, so example 1, some students were surveyed to find their favorite after-school activity. The result of the survey is shown below. 18 out of 19 18 girls and 9 boys said playing sports was their favorite activity. 9 girls and 2 boys said reading was their favorite activity. 13 girls and 9 boys said hanging out with their friends was their favorite activity. Part A, complete the frequency table to show the number of boys and girls who chose each activity. So, out of boys who preferred sports, boys who said playing sports was their favorite, that was 9. Boys who preferred reading was 2. And boys who liked hanging out with their friends was 9. 9 plus 2 plus 9 is 20. So for our girls, 18 prefer sports. 9 said reading was their favorite. 13 said hanging out with their friends. 18 plus 9 plus 13 is 40. They surveyed a total of 60 kids. Those that liked playing sports was 27. Those who liked reading was 11. And 9 plus 13 gives you 22 for those hanging out with their friends. So for part A, all we had to do is complete the frequency table to show the number of boys and girls for each activity. Part B on page 39 says complete the relative frequency table to show what percentage of each activity choice was chosen by boys and what percent was chosen by girls. Round each value to the nearest whole percent. So for sports, there were 9 out of 27. 9 divided by 27 is 33%. Which leaves us with 18 out of 27, which is 67% for girls. For reading, we have 2 out of 11, divide 2 by 11, and you get 18% of boys prefer reading. And then 82% of those that prefer reading are girls. And those that like hanging out with friends, the boys, is 9 out of 22. So of the kids that prefer hanging out with their friends, 41% of them are boys. And 13 out of 22 means that of the kids that prefer hanging out with their friends, 59% of them are girls. So you should be able to add these to get a total of 100%, 33 plus 67, 100%, 18% plus 82%, 100%, 41 plus 59% is 100%. Part C. Tim said since 18 girls but only 9 boys enjoy playing sports, then the girls must be twice as likely to play sports. Do you agree? Well, yeah, it's true that 18 girls prefer playing sports and only 9 prefer playing, are boys that prefer playing sports. But if they only surveyed 20 boys total, and they surveyed 40 girls total, they surveyed twice as many girls. So, this is not true. Because only 20 boys were surveyed. Whereas 40 girls were surveyed. Tim cannot assume that twice as many girls like sports. Because he asked twice as many girls the same question. Had he asked the same number of boys and girls, and he had received the same data, and he could have said that. But since he asked twice as many girls, he cannot assume that twice as many are offered by the sports. And that concludes our